And so this is what we have going on bonzai and how it's going to work. You make a couple commands and then you compose those commands together into this command, and then you should be able to do replacement. I mean, this completion should show up. That's what we want. As an executable, and it looks at its environment and stuff. It's its execution context, and it makes decisions about what to do next, including completion. So we're not going to actually call the method right now. We're just going to go ahead and call completion to test it being run from a command. I think the package is safe enough though, because it's safe to say that any compiled binary would be, the package scope could tell whether or not it's in the right context. So we're going to go ahead and make that into a package editor, which is VI. So this is a Markdown editor. I don't like rendered editors, so this actually shows me what what the Markdown is going to be. And then when I save it, it automatically commits it to GitHub, pushes it to Twitter, and posts the message. It's really not up to me, so it's like not even worth talking about. It just is, and I'm not going to convince Twitch to not run ads. So I accept my place in the universe, and I'm okay with it, but I want to manage it, so that's why I do it this way. Command box, in case you hadn't heard. And we've got our stuff here and some sub packages that we're going to be dealing with. And we might run into something called cyclical import problems. And I figured out a way around that. Trick we're going to do to break the cyclical imports problem in Go if you've ever hit it. It's really annoying, but it's there for a purpose. It makes compilation time the fastest in the planet. Go has the fastest compilation of any programming language, period, without question. And it's because of things like this that's done. And we're going to emulate this right now. As you get used to passing interfaces in the first place, you should be usually passing interfaces and not structs. But sometimes there's a minor time when you wouldn't want to do that. But generally speaking, just by passing interfaces, you will have already stopped yourself from having this problem. Because the way to fix the problem is to create two separate interfaces that are identical, at least in subset. So that the first package on the top has all of those methods, and the subset also has the same methods. The reason this works is because when the sub package is resolving its dependencies on the interface that's inside of its own package, it's just checking to see that those functions have been defined, that those methods are there. It doesn't care about the fact that it's also defined in the parent. So we did a go mod. Go mod init, a cyclic example foo. We're not going to put this on GitHub or anything, but I just want to have, did I spell it? Cyclical. I just wanted to show this. And then we're using Go 1.18, which you can get now and use since it's going to be out officially this month. And then we can go ahead and make a file in there, and then we're going to edit that file, and we're going to make something interesting in there. So let's see what we could do here. Package bar, etc. See in bar, which is down here, so it's in bar/bar.go. It's a sub package. We're gonna make a dependency on foo, and we're gonna use it. We're gonna break this by making a dependency on a does not yet exist struct, right? Now we're gonna add that. The import's not there yet, but that'll be there soon. A thing with no elements in it, but we have this receiver and we have a foo, so this can be called. And that will run, and that we're calling that from bar. And now actually if we save this, it should get it right. There we go. Cyclical example, and it knows where to get it. Have a problem, right? We do not have a cyclical import yet. I can install both of it. Well, it says it's not used, but I mean, that's a minor error compared to the other thing. We don't have the cyclical import problem yet, but I'm about to make it a problem. I was doing the log thing. I don't need to do that. So I can just call foo.foo here. And again, we don't have the problem, right? We can install bar now, and it'll install just fine. And we don't have the cyclical problem yet. So, but let's go ahead and add the problem by opening up foo.go and creating a dependency bar. Even though, it's not going to work, because when I call bar.bar, bar is going to need foo for something, right? Because we're passing a foo thing, right? So that's the problem. We actually have a cyclical import going on. It's a kind of contrived example, but you're going to hit it a lot. You'll hit it when when you're doing refactoring. You're like putting stuff where you think it would be nice to have it and organize everything separately, but you have this sort of interdependency on the other thing. And then you're going to start to hit this. So how do you fix it? Who gets the interface, right? What is more important to have the interface? They both need the interface, but who is going to be the main interface? In this case, that would be foo. So we're going to put an interface in foo right now. The interface, we're using a simple single method interface, but it doesn't have to be a single method. In fact, I have one that's got over like 20 data points, and I'm able to do this, and I'll show this later about how this works to fix a cyclical import problem in bonzai. So with data points, we have to tell the bar, as I said, pass interfaces, return structs. So we're going to change this to fooer, which resolves to the current package, and the cyclical dependency goes away. Because the dependency on fooer, on the fooer interface, is a local package dependency, and it doesn't matter. And anything that has a foo method, whether it's from here or it's defined as an interface that it belongs to another package, it still works because it's all got the same argument to it now. We can say, I want to call bar here, but I'm going to give it a fooer, right? And a fooer is going to be, we need to make a fooer. So we could say, we could even pass T to it. That fulfills the interface, delegate to an entirely different package that also can handle things with the same method set. So you can even put it inside of your own methods. As long as those methods fulfill the foo, you're good to go. Feel the foo. It's on github.com/rvxrob/lab/go. And inside of there, you'll see the cyclical imports stuff. And you can go read about that. But I'm going to be working now. If you want to see a more substantial example that's using this in the wild, you can see that. But I figured it was important. We want it to be easy to define these things. And it's public and all of that. We can still add an interface to help us bypass the cyclical imports problem, and also to create a read-only interface to the struct so that things don't abuse it. The first thing I want people to notice here is that this does not have any setters. A lot of these are just data points, right? And it's just fetching the string, and it's doing a return thing. That is very important. That means that this interface does not allow stuff to mess with it. It only allows it to retrieve it. Here, which is what we define similar things. But you see, we only have a subset. Because in this particular completion library, I don't need all the information from the command struct stuff. I just need this stuff. That's it. That's all I need. Function completion type. Function types are very unique. They're mostly just, just convenience when writing stuff out. And you do the function without the function type if you don't want to, and it'll do that. But I have to have that same type in both. I had this. I had a pointer to command, to a bonzai command, and that created a cyclical import. But since changing it to command, it eliminates the cyclical import and makes it safer. I want to get the API like totally fucking perfect before I do it. And I've been working on this API. This is like technically version 3 of the thing I've been doing for more than like 5-6 years at this point. So I have some opportunity to revise it. A command interface like this is one of the biggest things that's absent from Cobra. Cobra was made apparently before this was a popular thing to do, and it was well known to do this, and it really suffers because of that. This really simplifies the creation of commands. If you're running under bash context, I should be able to detect what my runtime is, and which could be bash or Z shell or some sort of REPL that somebody made application. That's what runtime is. So we should be able to detect that and then just hand off to it. So yeah, let me make a little clip about that. Yeah, I just want to say one of the best ways to understand Go is to clone the standard library and go through and read about that. We just noticed, for example, that you can make an example that's in the main package, which I did not know, and I want to go figure out how to do that. So that's what we're doing. We're going to go figure that out. To IO standard out. Okay, yeah. So, I mean, watch, if I change this and I click run, it'll change it to something else. You see how it said waiting for the remote server, and it gives you the output? That's pretty cool, huh? With the idea of how can we make it work with multiple shells in a modular way without causing too much complication or abstraction. And that seems to involve the idea of the runtime and detecting the runtime, but where is the runtime detected? When do we do that? That makes me sad. I think we need to have the idea of a runtime provider so that if somebody wanted to create another readline thing or something like that, which happens a lot in Go, that they could create their own runtime provider, and that could abstractly, be added in to exec. Right? You want to have it exec, shell things, VI or whatever, and it needs to know about that. And it needs to know about its runtime, whether those things are there. And that's more than just checking for the executable. That would mean it needs to know, well, was I run from run? May say, well, I want to be able to run under like this other runtime that this person made over here that is its own REPL, that is a multi-call that, like BusyBox, that doesn't have any of the normal commands, right? So in case we have a user that knows about multiple different runtimes and says, hey, I want to do something special based on this runtime. So where would they go to know that the runtime exists? Would they go to the internet? Would they go to GitHub? Where would they register runtime types? This particular person may want to support multiple runtimes. They might want to say, hey, I'm on this runtime and I'm on this runtime, but they would need to know that. So how much information do we give them about the runtimes that are available versus what they've provided on their own that we provide, and to create them as a part of a sub package within bonzai, so that if people wanted to provide additional runtimes, we could put them there, and then anybody using the library could pick from one of those runtimes to put those in their environment. The UFave CLI or the Cobra, they don't give a shit. They just say, hey, these are the shells that we support. Here's the runtimes. If you look at their completion, there's only so many isolated, finite number that they support. And I think that it's okay for us to do better the same. When you have like a really solid example of why you want something. Rust is, and they have generics for sometimes, yes. If I'm clunky and I change it, but yeah, for sure. Yeah, and that's fine. I think it's great. Yeah, this is definitely clunky. And this entire code, this is literally the same code for every different type that goes away as soon as I add generics. And I can't wait to do it. I haven't done it yet, but I can't wait to do it. So there it is. I'm a big generics fan, like more than I ever was before. This is functional. If you want to be functional, this is it. So you could actually make the case that Go has not truly been functional until now, because this is now going to allow us to do all kinds of amazing functional transformations, writing very minimal code. It is functional programming. It's like you take this input, transform it, and then you do this output, and then you type them together. That is 100% functional programming. I mean, there's some technicalities that make it different, but it is. It's functional. Unix philosophy is functional programming. Complexities of computer science until it gets me something. And so in order to make more Go code that's like Bash, I ended up having to implement filters which are functional and discovering that I needed generics. So you can give Bash credit for me loving Go generics. A whole bunch of lines of strings. You want to start dealing with arrays and things like that. Now you got typed things you got to filter over. And as soon as you're iterating over things like that, you want to be able to say, hey, I want to be able to iterate over anything. As soon as you want to iterate over anything, you need a generic. There you go. Because they turn Go more into Bash. Because I can implement Unix filters in Go the same way that they would work in Bash. That is the reason I love it. And, sue me.